This comprehensive Python data science course covers the essentials through theory, demos, and real-world applications. With 2 detailed projects, this course is designed to provide practical experience that will prepare you for real-world data science. You'll gain hands-on knowledge in data analytics, A/B testing, and business intelligence.
If you are an aspiring data analyst, data scientist, or you are aspiring to get into the field of machine learning or AI, then mastering the basics of data and analytics is your starting point. In this comprehensive 6+ hour course, we are going to start with the Python implementation of data analytics. We are going to look into the data analytics basics when it comes to putting that in Python programming. After this, we are going to get into the A/B testing theory, which is fundamental for any data analyst or data scientist who wants to get into the A/B testing theory, which is fundamental for any data analyst or data scientist who wants to drive the experimentation changes in the product like UX design to the algorithms using the data. This course will consist of 3 parts. The first part will be dedicated to the Python data analytics course. In this Python data analytics course, we are going to cover the basics of performing data analytics, including data visualization and data preprocessing in Python. After this, we are going to get into the second part of the course, which consists of the theory of data analytics and data-driven experimentation. This is fundamental for any data analytics and data science professional. Here you are going to learn the A/B testing theory, starting from the hypothesis, the business problem, up to the point of conducting a data analysis on that collected data to make a data-driven decision for different sorts of online problems. Then we are going to get into the third part of the course. In this third part of the course, we are going to conduct the 2 end-to-end portfolio projects. The first one will be related to the A/B testing, where we will conduct an end-to-end A/B testing online analytics-related project, which you can also put on your resume. And in this 1/2 hour, we are going to cover from the basics of A/B testing results analysis in Python to the actual implementation of it and conducting your data analytics in Python programming. And finally, the third part of the course will consist of 2 separate end-to-end full data analytics projects. The first one will be about online testing, where we will use the data analytics as well as Python programming to derive the landing page UX design decision on the landing page of lunartech.ai. And then the second portfolio project will be another 1/2 hour end-to-end data at lunartech.ai. And then the second portfolio project will be another 1/2 hour end-to-end data analytics project, where we are going to look into the data analytics for a Superstore project. So those 2 projects, in total of 3 hours, will be a great way to implement the theory into practice in an actual business, real-life setting. I'm Tatev Vaslayan, data scientist and AI professional, and I've been in this field for more than 5 years. I'm co-founder of Lunartech, where we are making data science and AI accessible to everyone, individuals, businesses, and institutions. So here is what we are going to cover as part of this. Individuals, businesses, and institutions. We are making data science and AI accessible to everyone, individuals, businesses, and institutions. So here's what we are going to cover as part of this full data analytics course. In the first part of the course, we are going to cover the data analytics in Python programming. So it is expected for you to know some basics in Python, but not more. we're going to learn how to load data in Python using pandas, how to do data wrangling and data preprocessing using libraries such as NumPy and dpandas. Then we are going to look into the data preprocessing techniques, how to do sorting, filtering, as well as data aggregation, how to join data using different joins, including inner join, left anti join, right join, how to do different joins, including inner join, left anti join, right join, how to do different statistics-related tasks, including calculation of data, descriptive statistics for our data using Python. Then we are going to do data sampling in Python. We are going to learn different data sampling techniques. And we are also going to look into data visualization in Python, which is really important as a data analytics professional when it comes to bringing the theory of data analytics into practice. So after this, once we are done with the practical programming section for the data analytics in Python, we're going to get into the second part of this course, which is about A/B testing. Here, we are going to look into a quick high-level theory behind A/B testing, and then we are going to dive deep into it. We are going to learn this idea of A/B testing, online experimentation, and how the data analytics is relevant for A/B testing. And we are going to learn this entire cycle of A/B testing, from the design up to the data analytics of the final results. Be prepared to learn here the concepts like primary metric, the design of the test, how you can design a proper A/B test, including choosing the right parameters for your test, calculation of the minimum sample size. So as a prerequisite for this part of the course, it requires for you to know some fundamentals in statistics. So understanding this basics behind probability theory, this concept behind normal distribution, how you can use a sample to derive insights about your entire population. And once we are done with this theory behind A/B testing, and we have also learned how you can conduct the data analytics and final data analysis for your A/B tests, we are ready to go into the third and final part for our data analytics full course. In this third part of the course, we are going to conduct 2 end-to-end case studies. In the first one, we are going to conduct a data-driven decision-making for Lunar Text landing page, where we are going to use data analytics, data visualization, as well as A/B testing to understand whether we need to replace our current button. So here, expect to use Python. In this 1.5 hour course, we are going to conduct data wrangling, data preprocessing, also data visualization, and then we are going to analyze our results and make a decision by using the theory that we learn as part of the second part of the course, as well as the programming that we learn as part of the first part of this course. Then, once we are done with this first end-to-end portfolio project, we are then ready to go on to the second project as part of this final part of the course, which will be about a pure data analytics case study. In this case study, we are going to conduct the data analytics for our Superstore. So here we are going to start with the overview of this analysis, and then we are going to analyze Superstore customers. Then we are going to see what techniques we can use and how we can conduct a Superstore customer segmentation analysis in Python. Then we are going to analyze the revenue of the Superstore by customer segment. After this, we are going to explore the customer loyalty at the Superstore. And then we are going to finish off with the insights that we derived based on this analysis for our customers from the sales and just in general. So we are going to analyze the sales of these customers by segment, and then we are going to conclude. At the end of this course, expect to learn all the essentials for your data analytics journey. So without further ado, let's get started. Hi there, and welcome back. In this demo, we are going to talk about how to load data and view this data in order to obtain more information about a certain data that is provided to us. We're going to learn how to load CSV files, how to load TXT files, how to load Excel files, as well as JSON files, and also how to load SQL database. For this one, we are going to use predominantly the pandas library, a library that we spoke about in the previous demo, but we are also going to use some other libraries. All right, so without further ado, let's actually go ahead and learn how to load CSV files in Python. So for that, the first thing that I'm going to do is to import the pandas library. Import pandas as PD. And then the next thing that I'm going to do is to pick the name of the CSV file. So you might notice that in the left-hand side in our PyCharm, you can see that we have a file called %bachelor's_woman_USA.csv. This is a CSV file containing the following data. So you can see we have information about the year, agriculture, architecture, art and performance, etc. So you might have already guessed that we are dealing with the data that describes the percentage of the females that have completed a bachelor degree in the corresponding fields and the corresponding year of it. Well, let's go ahead and load the data in the Python. For that, what I'm going to do is to use this pandas library. And as an acronym, we usually always write a name of PD for the pandas. So let's go ahead and name our data frame, which we will call, let's say, data_CSV. And this will be equal to, and here we need to take the name of the library we are going to use, which is PD, which stands for pandas, dot, and then read underscore. As you can see, we are getting already many options. So we have read underscore CSV, then we have read underscore Excel, we have read underscore HTML, JSON, Parquet, Pickle, SAS. So here you can see all sorts of data formats that you can, file formats that you can import. And we are going to learn a few of them. And those are the most popular file formats that you can expect whenever you are entering the data science field. So as we have a CSV file, we are going to use the read underscore CSV option. And within the parentheses, we always need to specify the name of the file we are dealing with. So you always need to put the name of the file as it's a string, so within the quotation mark in here. So let's go ahead and actually print our data frame to see what is actually going on. Here we go. So you can see we are getting our data nicely. So we see that the headers is recognized. So we see the column names. We see also here the indices corresponding to our observations. And this is really a great way to look into your data for the first time. In the same way, by using exactly the same function, so read underscore CSV, we can also load a TXT file. So TXT and CSV files are pretty similar to each other. So in case of CSV files, which stands for comma-separated values, we do not usually specify that the separator is comma. So as you can see in here, this is a CSV file, and the values corresponding to each of the columns are separated by a comma. And if we're dealing with a TXT file, in the TXT file, we don't really know what the separator can be. Sometimes it's the comma, sometimes it's the space, sometimes it can be entirely different character. So it's really up to the data that is provided to you. But one simple way to load a TXT file by using exactly the same function, so the read underscore CSV, is the following. So here we have two different TXT files in here. We have the student grades.txt and the student schools.txt. Go ahead and use them. So we have data underscore txt, and it's equal to pd.read underscore txt. And then here within the parentheses, we have, let's say, student and then schools.txt. So this is the path. But before moving on towards the other arguments, let's actually go ahead and click on this to see how it looks like. So you can see we are dealing with a TXT file where we do have the header. So we have the name, school ID, and country, which all represent the name of the corresponding columns. As you can see here, we have the name, here we have the school IDs, and here we have the countries. And another thing that we can notice is that we are dealing with a separator in the form of commas. So therefore, what we need to do is to provide in here, by the way, instead of TXT, we will just use CSV for simplicity. And here we will mention that the header is equal to 0. So the first row corresponds to the header, which means that that row should not be counted as a data. And then the next argument that we will use, just for knowing how to use it is the separator. So here we will mention that the separator being used to separate each column's value in the row is the comma. But if you were to be supplied with the data in a more difficult format where you had a different separator, so let's say the separator is percent symbol, then here you need to specify that your separator is this symbol. So whatever the symbol is used, the character is used to separate your data, that's exactly what you need to put in here, such that PyCharm can understand when it needs to cut and needs to take that value and say that this value corresponds to that specific column. And then the same holds also for the header. If your header is not present, then you need to specify that in your argument header. All right, so let's go ahead and load this data and see what is underneath. So print data underscore txt. Here we go. So as you can see, we nicely get all 7 rows. So the first name is Tina, the last name is Anna, and then the country, Canada, and the last one, Armenia. So let's go ahead and check it. In here. So I always recommend to check the first and the last rows of the database to make sure that you correctly have loaded your data and you are not missing any information from your database. The next thing we are going to learn, and you have a name of your first sheet equal to sheet 1, and then the second one corresponding to another name, and you have multiple of those pages in your Excel file, is how to load Excel files. So let's say you have an Excel file and you want to load only the first page. Well, for that, what you can do, in here, I'm not going to look into a specific Excel file. Feel free to search for an Excel file or maybe one that you can create yourself, and then create your own pages within your Excel file and try to load that in Python. But for now, let's assume that we do have that Excel file in our PyCharm environment, and we are going to load that. So data underscore Excel will be the name of the data frame that we will store our data. And then the function we can use is pd dot, and then read. And then here we already get a recommendation from PyCharm, read underscore Excel. And then here we have file underscore XLSX, which is a common extension of the Excel file. File.xlsx is the name of your Excel file. And here I'm making an assumption that your Excel file is within this Python for data science or your own folder, the one that you are currently using in PyCharm. So here, then the next thing we need to specify is the exact spreadsheet we are looking into, because otherwise you will get an error in a PyCharm, and PyCharm will not recognize where exactly it needs to look for the data. Therefore, we need to use this argument called sheet underscore name. And here you need to specify the name of your exact spreadsheet you are looking for. It can be that it is the default acronym usually used in Excel, but in case you have renamed it or someone has renamed it, then you need to specify that specific name. So it can be, for instance, first spreadsheet, let's say, if that's the name of your first spreadsheet, or it can be sheet 1, which is usually the common convention used in Excel whenever you are not changing the name of your spreadsheet. And this is how you can read an Excel file. I won't be running this code because we do not have the file .xlsx in our folder, but this is something that you can experiment yourself. And another common file format that you can expect is the JSON format. Here, once again, we are following the same idea as in case of Excel files. So feel free to go ahead and look for JSON file online, download it, and try to load that into your PyCharm environment. But this is the way that you can load JSON type of data. So data underscore JSON is equal to pdata.read underscore JSON. And then here you can specify the, let's say, JSON file.json. So this will be the name of your file. We can also make this more convenient. So let's make it file name. Here also file underscore name. And this is the only thing that you need to specify. So this will be the name of your file. And here, once again, I'm assuming that your file underscore name.json is actually in this folder that you are currently running. Otherwise, you need to specify the exact path of the file that you have. So once you write this, then you should be able to successfully load your JSON type of data in your PyCharm. And then finally, we will look into a way to load SQL databases. So SQL databases are common database format whenever you are working with big data. This is very common in the field of data analytics, but I think it's still worth to know at least the commands and the library you can use in Python in order to load this type of data. So let's actually go ahead and import the corresponding library we can use to load SQL database. And the library is called SQL TE3. So for that, we will do import and then SQL and then ITE and then tree. Then what we need to do first is to make a connection with the SQL database. And that's exactly what we can do by using then ITE and then tree, then SQL and then ITE and then tree. Then what we need to do first is to make a connection with the SQL database. And that's exactly what we can do by using this library. So connection DB is equal to SQL ITE tree dot connect. And here we need to specify the name of the database we are dealing with. So database underscore name dot, the extension is DB for database. And in this way, you will make a connection with the corresponding database. The way SQL works is that in SQL, we are creating databases, and within each database, we can have multiple tables, and each table has its own name, and then corresponding database. The way SQL works is that in SQL, we are creating databases, and within each database, we can have multiple tables, and each table has its own name. And then within each table, when we are loading that table, we can then run queries. I won't go too much into details about what is SQL, how you can use database, how you can create tables, and how you can run queries, because that's outside of the scope of this course. But I would highly suggest you to at least learn the basics of the SQL. It's not necessary to enter the field, therefore it's also not included as part of this course, but it's good to know at least what SQL is, and also how you can use it, and what is the functionality of SQL in the entire world of data science. So I will include some resources about SQL and the usage of it in the resources section. But just know that in order to be a technical data scientist, at least to enter the field of data science, you do not need to know SQL. It's something that I would highly suggest you to learn as you grow in your career, but it's not a must know. So once we have made the connection with our database called database_name.db, then we can specify the exact query that we want to run. And in this specific scenario, what we mean by the query is that we will use the commands commonly used in SQL in order to select all the rows within a specific table. So in our database, we can have multiple tables. And here I will assume that we have a specific table from which we want to import, let's say, the first column only. For that, what we need to do is to do a query. Let's call it a query. Let's say it's our first query, query_1 is equal to, and then here we have quotation mark, and then select. This is a common way of specifying that we want to select specific variables from our table. And here we can specify the name of the column that we want to import. Let's say call_1. And then we need to specify from. And here we will specify the table_name. And in this way, the query1 will then go ahead and select the first column from the table with the table_name. So this is one way of running a query and selecting just one variable. We could also write a query, we will call it query2, and this will select all variables from table_name. Select. And then here, what we need to do is use star. And in SQL, whenever we are saying select star, it will go ahead and select all the columns included in that data, something that we usually prefer instead of just selecting one variable. So you will select certain variables only if you are specifically looking for those features. But otherwise, I would highly suggest you to include all the columns. All right. So by the name of the data frame we want to load this data in, and then we read underscore. As you can see, we already see something. So here you can see that we have three different functions we can use. We can use read underscore SQL. We can use read underscore SQL underscore query. Or we can use a read underscore SQL underscore table. They do differ in the way they import the data. So for one, for instance, you can specify also the schema, and another one you can specify the index of the column you want to import. The most generic one is the read underscore SQL, similar to the read underscore CSV. So we are going to use that one. And the next thing we need to specify is the query and the connection. Is to specify query underscore to. And then next thing I need to do is to specify query underscore 2. And then next thing I need to do is to specify the connection. So once you run this code, what this will do is to make a connection with your SQL database. It will then specify the query, and it will go ahead and select all the features and import all the features from a table called table_name, all the variables, and it will then be stored in the pandas data frame. This is all for this demo, and I will see you in the next one. In this demo, we are going to continue the process of looking into the data. As in the previous demo, we learned how to load different sources of data. And in this one, we are going to look into it. We're going to learn how to explore the data and how to pre-process it. We are going to discuss the inspection of the data, getting information about it, getting to know what the shape of the data is, how to identify missing values, how to drop the missing values, how to fill in missing values, how to get the type of the data you are dealing with, how to access different rows in your data. Data frame by using the infamous ilog and log, and what is the difference between the two. So from the previous demo, we still have the CSV file, and we saw that we got this data structure in the CSV file describing the percentage of the bachelor degrees consisting of women in the USA. So this is how the data looks like. We had the year, agriculture, architecture, art and performance, etc. And then in total, we got 18 columns in this data frame and 42 rows. So the rows are those observations, so you can see in here, and the columns are all the features included in the data frame. And we got only one feature describing the year, and the rest of them are all the names of different sorts of bachelor studies. So as you can see, we have agriculture, architecture, we have social sciences and history, public administration, etc. The first thing we are going to look into how to use the header functionality in Python in order to get a snapshot of the data. So what we can do here is to write down the name of the data frame, so data.csv. And what we need to do is to do dot and then head for the header. And then here inside in it, we can leave it empty. So when we do that, what we will get is the following output. So let's actually go ahead and remove that one from the printing temporarily. As you can see, it will print for you the first 5 rows, but all the columns. And if we specifically are looking for X number of rows to be presented as part of the snapshot, then we can specify that as part of the head function. So in here, for instance, we can say show to us the first 100 observations in this data frame. And in that case, it will print for you the first 100 observations. But as we have only 42 rows, it means that it would need to print for you all the rows. If we change this to 20, let's say, then in that case, we will get the top 20 observations present in the data. And this is how it looks like. All right, so this is about header function, just a good way to have a first look at what kind of variables you have. In case of all the rows, top. If we change this to what is the number of observations you got by looking in here, what is the number of columns you got, and also what are the different sorts of variables you got. and the data types in your data frame. Just by visual inspection, you can see that we have, for instance, the year column, which consists of the integers. We have the agriculture, architecture, and all these other variables that are of a floating number type, which means that we got a number, and then we got dot, and then what comes after the decimal points. And if this header function will print for you the top X observations, we can do exactly the same only from the bottom observations. And for that, we can use a function called tail. So we can print, for instance, the last 20 columns. By using this data underscore CSV dot tail, and then within the parentheses, the amount of rows that we want to see from the bottom up. So let's go ahead and print that. And as you can see, if the header function will showcase the first 20 rows, the tail function will showcase the last 20 rows. So you can see 22, 23, up to 41. So this is a great way to see how the first few rows look like and how the last few rows look like. The next thing what we can do is to use this info function in order to obtain more information about our columns, so their data type specifically. So this is the output of the info function, and this is the number of columns you have. In this case, the year is the first column, the agriculture is the second column, and then the social sciences and history is the last column. And then we have the count of the non-null values. As you can see, all the columns have 42 non-null values, which means that we do not have any missing observations. Then we have the data type corresponding to that specific feature. And we already saw from the snapshot that the year was the only variable of integer type, and everything else was floating data type. And this is exactly the confirmation for data observation. The next thing what we can do is to identify the missing values and drop the missing values. So from this, we can already see that we do not have any missing values, but let's actually go ahead and learn how we can do that. So let's say we want to drop all the missing observations. For that, what we can do is to do print, is to actually take the name of the data frame, CSV, and then what we can do is to do drop, and then NA, and then parentheses. So in this way, you will be dropping all the NAs, so all the cases where your observation has an NA for that specific column. So as we do not have any missing values in our data frame, this will not do much to our case. But I think it's really important to know how to drop missing values in case you want to quickly remove them from your database. Let's say you do not want to drop your NAs, so the missing values in the form of NA, but you want to fill them with a certain value. What you can do is to use this fill NA function, and within the parentheses, you just need to specify what is the value that you want to use to fill the NAs. So in here, you can, for instance, decide to put null instead of NA, and this will simply go ahead and fill all the values where it's written NA. It will replace it with null values. So let's say you have another issue with your data. So you have rows that are exact copies of each other. One function you can use is what we call drop duplicates. So for that, you simply need to take the data frame's name, and you need to do drop and then underscore duplicates, and this will quickly remove all the duplicates from your data frame. So let's actually go ahead and change the CSV file and see whether we can nicely remove the duplicates. So let me copy paste this a few times. And as you can see, it's the exact copy of the third row. And now we have it in the fourth and fifth and sixth rows. So let's go ahead and check whether this drop underscore duplicates really removes those duplicates. So let's print the actual CSV file before the can. So let's say you have another issue. We'll simply go ahead and fill all the values where it's written NA. It will replace it with null values. So let's say you have another issue with your data. So you have one and this them with this parentheses usual. It will simply null values. Rows that are duplicates. So for that, you simply need to take the data frame's name and you need to drop and then underscore duplicates. And this will quickly remove all the duplicates from your data frame. So let's actually go ahead and change the CSV file and see whether we can nicely remove the duplicates. So let me copy paste this a few times. And as you can see, it's the exact copy of the third row. And now we have it in the fourth and fifth and sixth rows. So let's go ahead and check whether this drop underscore duplicates really removes those duplicates. So let's print the actual CSV file before removing the duplicates and after removing the duplicates. In here, let's see. So in here, you can see that this is the data frame with in total of 45 rows because we just added 3 additional rows. So previously we had 42, we added 3, so we end up with 45 rows and the number of columns is the same. And then we apply the drop duplicates function. And as you can see, after using that function, now we once again end up with the 42 rows. And if we go ahead and look into the specific column we duplicated, you can see that we got only 1 row corresponding to this year. And this is how we know for sure that drop underscore duplicates really works and it will remove the duplicates from your data. The last thing we will look into in this demo is how to access certain rows in a data frame depending on their index type. So sometime, and actually most of the time, we will get a data frame that has an integer as an index. And that's also what we got in our data frame. As you can see, the index is 0, 1, 2, 3, 4. So it's in the integer format. But there are also occasions when you will get your data frame with an index that is of string type. So you will see that instead of the index 0, 1, 2, 3, for instance, you will have A, B, C, or A1, A2, A3, etc. So depending on this nature of the index that you are dealing with, you can then use either the ilog or the log functionalities in Python in order to access different rows in the pandas data frame. And this is, by the way, a common question you can expect during your programming-related data science interviews. What is the difference between the ilog and log and how you can use them? So let's start with the ilog as our data frame and how you can use them. So let's start with the ilog as our data frame already contains an integer-based indices. And let's say we want to access the data in the index 10. So this is the row that we want to access. Therefore, what we need to do is to take the name of the data frame, so data underscore CSV, and then we need to do dot and then ilog. And then in here, we need to specify the row that we want to access, which is a 10. And let's go ahead and print this to see whether we are getting the correct data. And let's verify that by looking at the year. So as you can see, the year is in incremental order, and we do not have duplicates in the year. So therefore, if we see that the year is equal to 1980, then we have selected the right data and we have accessed the right row. So this is the output. And as you can see, the year is equal to 1980. And this is all the information that is stored in the 10th row. And in this way, you can access any row that you want in your data frame. So it can be, for instance, the first row or the last row, but it can also be a row somewhere in the middle that you want for some reason. And if you want to access a specific column instead of specific row, what you can do is to use, again, the log function. So data.log. And here, instead of providing just one argument, you can then provide two arguments. So we always have the rows in the beginning, and then we need to specify the columns. And in case of we need to specify the columns. And in case of what we did was to access the specific row. Therefore, we specified only the X. But if we want to access a specific column, we also want to specify the rows that we want to include. Then we need to specify both the index of the rows and the index of the column. So let's say I want to access the column A2. In here, I will then specify A2. And as I've specified here a column, this means that I want to take all the rows, so the indices corresponding to all these values. So let's see what the output of this one is. And as you can see, here we are getting 4, 5, and 6. So the value corresponding to the index X, Y, and Z. And this is actually the column A2. So in this way, you can specify not only the rows that you want to access, but also the column. So let's say you only want to access a specific value in that column. Let's say you want to access the second row and the second column. In that case, what you need to do, I'm sure you already have guessed it, is to specify the index of the row and the index of the column that you want to access. So the index of the row is Y, and then the column that we want to access is A2. So this is the number that I'm chasing. Let's see whether this will provide the value. And as you can see, it provides 5. And let's also look into the case. All you want to access is A2. So this is the number that I'm chasing. Let's see whether this will provide the value. And as you can see, it provides 5. And let's also look into the case when we are dealing with a string-based index. So let's create for that a small data frame, and it is the following. Let's look into it. And as you can see, this is the small data frame that has indices X, Y, and Z. And let's say we want to access the data that is stored under the index X, so very first row. Well, what we need to do for that is to, once again, take the name of the data frame. And instead of using ilog, this time we need to use the log. And then the index name, which is similar to what we saw before. So the index name is X. That's what we want to access. And let's actually see what is the output of that. Print. Here we go. So as you can see, the first value is 1, the second value is 4, and the last value is 7. So by using the log functionality, we can access the row in a data frame where the index is of string type. But if you go ahead and you use the ilog in here, you will see that you will get an error. And the reason for that is because ilog doesn't allow you to search with a case when your index is of string type. And for those cases, you always need to use the log function instead of ilog. Hi there, and welcome back to another demo. We are going to talk about 3 very important tasks that you can perform as part of your data analysis and data manipulation toolkit. So we are going to learn how to do filtering, sorting, and grouping in Python. Data analysis and manipulation involve working with large amounts of data, and you can definitely expect this as part of your data science project. And then what you need to do is to extract meaningful insights. In this context, filtering, grouping, and sorting are really important techniques that allow us to organize, extract, and analyze data efficiently. Python has a very powerful tool, library called pandas that we also saw as part of the libraries discussion demo, which can be used in order to perform grouping, filtering, and sorting in a very simple way. So when it comes to grouping data helps us to analyze and summarize information and data based on specific criteria. Here we need to have at least one variable to do the grouping based on, but then you can also add extra other variables such that you can aggregate your data not only on one variable, but on multiple variables. So let's say you want to group your data based on the gender or based on the region, and then you want to perform some descriptive statistics calculation. So you can calculate the mean, for instance, the standard deviation, the variance, the median, the mode, the minimum, the maximum. You get the idea. So you can then categorize your data into certain groups. And this way you can group your data, and then you can obtain some meaningful information and analyze your data. This is usually a very important part of your data preparation process. Another thing we are going to talk about is how to filter the data. So whenever you are filtering your data, it helps you to extract subsets of data based on specific condition. So let's say you know a specific year that you are interested in, or you are interested in a specific region, you are interested in a specific characteristics, then you can use filtering to filter your data, to select only a subset of observations from your data, and to perform all the analysis, calculation, and training of your model based on this specific subset. Or it can also be that you want to identify the outliers in your data or the noise in your data, and you want to identify the 99 percentile or the first percentile. So you want to identify the largest or the smallest observation in your data and remove them from your data such that you won't be dealing with the problem of overfitting, as an example. Another thing that we are going to learn as part of this demo is sorting. So sorting data helps you organize information in specific order. It can be in an ascending order or in a descending order. It can help you to visualize your data. It can help you to identify certain patterns, find extremes or outliers in your data. And sometimes it's also used as part of the time series analysis, or for instance, to look into the sales performance to identify the worst performing shops or the best performing shops. And it's essential part of the re-ranking and recommender systems. So whenever you are dealing with search engines, recommender systems, anything that relates to the order and importance, then sorting data comes really handy because you want to show the best information, the most important information to your customers. And the way that you can do that is by sorting your data. So when it comes to the ascending versus descending, the ascending relates to the case when the smallest values are at the top, and then the values would then increase, and then at the bottom you have the largest observations. And whenever it comes to the descending order of the sorting, then we have the largest values at the top, and then the values would decrease, and then the smallest values will be at the bottom. So here I created a very simple data frame using Pandas library. And here we have 4 different columns. We have the name, the age, the salary, and the department of an employee. And as you can see, we are dealing with 8 observations. The name and the department are of string type, and the age and the salary are of integer type. And what we want to do here is to sort our data under the data frame name data with respect to the salary, such that in the beginning we have at the top we have employees with the smallest salary, and at the bottom we have employees with the largest salary. So what we expect is that this person, so this corresponds to Sana. Sana at the age of 19 from the Department of Operations should be at the top because this person earns the least. And then we have the largest earning, so the highest earning person, which is named Bob, and Bob with the age of 20 should be at the very bottom because we want first to sort our data based on salary in an ascending order. So for this, what we can use is the default pandas function called sort underscore values. So data.sort underscore values. So as you can see, we are already getting a recommendation for this function from Python. And here you need to specify based on which variable you are sorting. And then you need to specify whether it's an ascending or descending. So the reason why we need to specify the variable's name based on which we are sorting is because here we could have also sorted the data based on the age. But instead, what we want to do is to sort the data based on salary, such that the highest earners will be at the bottom and the lowest earners will be at the top. Therefore, we need to specify that by is equal to salary. And then when it comes to the other parameter or the argument in this function, which is ascending, this is a Boolean type of argument. So when ascending is equal to true, which is the default value, then it means that we are sorting our data frame based on an ascending order. But if we want our data to be sorted in a descending order, then what we need to do is to change this value. So then the ascending argument should be equal to false. So let's actually go ahead and see that in the implementation. So here we need to specify by is equal to, and then the name of the variable based on which we are sorting, which is the salary. Then the next thing what we need to do is to mention ascending, which is the second argument. It's a Boolean valued argument, so it can only take values true and false. And the default value is true, which means that we are sorting our data in an ascending order. I could have also skipped this argument. You can see in a bit that we are getting exactly the same result when we are mentioning this argument ascending equal to true and without mentioning this argument, simply because the default value is equal to true. So let's actually go ahead and remove this for one case and leave for the other, such that you can see that both will result in the same output. Here we go. So let's also add a line in between to make sure that we are getting everything nicely printed. Here we go. So as you can see here we are getting, as expected, Sana at the top and then Bob at the bottom. And in this way, you can verify that your sorting occurred successfully and you have done it in an ascending order because the salary is increasing and the lowest salary is at the top and then the highest salary is at the bottom. So the other thing that you can see here is that we are getting exactly the same result when we are mentioning the ascending equal to true. So this is simply because there are certain arguments and the arguments have certain default values in Python. And whenever you want to have the default value as your argument's value, you can also skip that argument and you don't need to mention that specifically. Therefore, this results in the same output as this line. But if we do want to change the order, so we want to have another value corresponding to that argument, which is not a default value, then we need to change that. And we need to specifically mention what is the value that we want, which means that if we want to order this data, so we want to sort this data based on salary, but in this sending order, we need to use this argument, and instead the true, we need to change this to false. Because if the ascending is equal to false, it means that the descending is equal to true. Hope this makes sense. So let's go ahead and print this. Here we go. So as you can see now, we have exact opposite of what we had before. So we have now the highest earner, Bob, with the age of 20, with a salary of $220K from the tech department at the top. And then the salary would decrease accordingly. And then at the very bottom, we have Sana with an age of 19 with a salary of 10K from the operations department because she's earning the least. So this is about sorting. This is all what you need to know. Do keep in mind about this descending and ascending and how you can use the parameters in this function in order to sort your data accordingly. Another thing we are going to learn today is how to group your data. So let's say we want to group our data based on a department. So we want to know per department
LDs at the bottom. GA certified before I was GIA certified. Mr. M and Cash anytime you see me, you know. On feet records, play a duck to catch a duck, you know. Tricking niggas who tricking niggas, you know. Supercar driving, brush screen flying, designer win, golden child, you know. When? Weezy out of here. Let's go. Hopping off a plane to a Mac. 100-time platinum, fuck a plaque. Bulletproof, the tires run flat. Cutthroat, I give him one chance. Slaughter out and gave him one band. 25 cars, one man. Driveway like a mini dealership. He went sour, cut the business with him. Crack smoker, I was living with him. Weird hoes, I ain't dealing with them. Overseas, they love a real nigga. She don't like it, but she deal with it. Rari's back to back, that's tough. Heroes round the corner, that's us. Putting on stuff, bitch, just flip phone, black Nike tick. We done it all with niggas. Boss man name on the check. These first ones come through trim. Dipset, Jim Jones, ball. Life of a fucking hustler, holler. She know not to text me, I'ma call her. Bro in prison, living through a pain. Feel well, I don't see a scratch. She ain't mine if she don't got me tatted. OCD me everything intact. Bitches tryna play me like I'm wet. Real P, I bet I go for that. Riding through the tray in all black. Pulling up on Pluto in the six. Hood full of dope slanging trickster. I come from that foe, I'm a real one.
Yeah, nigga, King Spider back. I don't even believe I was locked up for real, for real. I was having my way the whole time, fool. Know what I'm saying? 2 lamb coops, 4 lamb trucks. Pulling up with the fuck. Neck, wrist, finger, slush. Order 100 G's, that's us. New rose color in that truck. Dog on the side like a bus. Shawty mad, ain't going back and forth. Never heard a rich nigga fuss. Heard these niggas going outside. Robbery truck came with a bag. Only fucking overseas shit. These US bitches kinda bad. College bitch, I made her leave a frat. Fuck my brother, gave the bitch a pass. Trapping in the studio, I'm glad. Break a bell to drink and get the trash. I was taught to pay a bitch to leave. I go Burt Chanel for the fleas. 4 I'm at a time like a she. I been on a boat screaming skis. Saint Laurent, they bring it to the beach. She was watching key in Middle East. She snotted all the key. Got her screaming RP the key. Our niggas can't stand us. Doggy, put your mans up. Walked her down in land guns. Pocket full of grandparents. Old school to Trans Am 1. Cullin' in the ambulance 1. You good, your mans can't come. I don't give a fuck about nothing.
Yeah. Ski. Ain't say gang, hope it don't thick like syrup. Elevator pad at the crib, shopping bags all on the floor. Never seen me twice with a hoe. Backyard vibes by the ocean, driveway look like a car show. 350 million on the go, custom leather Pucci on the dope. 50 birds a dog on my wrist, cocaine jumping off my bitch. 32 shots with the glitch, talking Vicks, then we talking Chris. Micro mini with a beam, print the side holes and Celine. Kicking out the millions like a beam, push a button and make your mama green. Eat it up, she working for a boss. Out the country, living like a boss. Princess cut ain't showing not a flaw. Graduated, cooking up the raw. Pushing skateboard, Tony Hawk. Cranking up the car when I talk. Alligator heard me and stuff. Drop $8 on the truck. Codeine bottles, they for us. Put them legal sticks on the bus. Off tour straight to the pit. 3 bad bitches getting hit. Solitaires made the eyes squint. Smell the dirty money through the vents. House full of dead presidents.
When?
Spider.
Hey, say gang.
Yeah.
The Wagster. Turn me your song. Yeah. Okay. Money on money, these millions, you dig? I'm spending this shit on my bitch and my kids. I'm sending the bit, not the beans. This motherfucker pink slip, nigga, no rent. I don't want you gonna do nothing if I gotta be the one tell you to spend. These fuck niggas telling for nothing and I gotta be the one calling them friends. Drop top Rolls Royce, I don't know the kind, I don't know the name of it. Fuck this little bitch last night and this morning, but I don't know the name of it. She told that pussy she don't know nothing about him and they fuck their fame up. We want the same mud, not the green, my nigga, the same mud. Mommy, you a thigh. I don't want shots. Brother, you a rat. My brother. Twin, you a pet. Running through sex. Hey. Louis V. Slacks. Hermes trench. Swim pool heated. Ooh. Yeah, she ain't tryna eat it. She ain't tryna what? Shawty, you can beat it. Drink a 2 liter, ride a 2-seater, round with an eater. Calling me Poppy, I'm calling her mommy, and senorita. I ain't been cocky, but I've been putting on Essence Beepers. Fuck me good the first day, a nigga might keep her. Blowing money fast like a fucking cheetah. I've been in the trenches filled with hyenas. Boo got a spider, whipping that bitch from the side. Money on money, these millions, you dig? I'm spending this shit on my bitch and my kids. I'm sending the bit, not the beans. This motherfucker pink slip, nigga, no rent. I don't want you gonna do nothing if I gotta be the one tell you to spend. These fuck niggas telling for nothing, and I gotta be the one calling them friends. Oh God. Drop top Rolls Royce, I don't know the kind, I don't know the name of it. Fuck this little bitch last night and this morning, but I don't know the name of it. She told that pussy she don't know nothing about him, and they fuck their fame up. We want the same mud, not the green, my nigga, the same mud.
You identify my bitches with APs. She ain't got an AP, she is not mine.
You cold.
Anything?
He cold.
She belongs to the streets. Spoil little bitch went petty. Clothes go snake, she a Betty. Transport far and go slatty. Dogging out a hole like Shaggy. Cutter went spit, went caddy. Pull up, cutter, we ready. For the out, bitch, I'm petty. Ice style bowling these spaghetti. First off, gotta go get it. Talk, let's do more spinning. Walk down, shit, get drenched. Turn the whole city up, lit it. Bad bitch, coulda went video. Savage, 21 killers. Brad bitch, rhyme with your sister. Dog ass hoe, you a thotty. Bro, turn cop, new body. Twin, you red, you smoke. Shoot him in the head, you the goat. Coulda went fed, went broke. Trap nigga living off the ocean. They found him the roads, I don't know. The eaters go everywhere I go.
Money on money, these millions, you dig? I'm spending this shit on my bitch and my kids. I'm sending the bit, not the beans. This motherfucker pink slip, nigga, no rent. I don't want you gonna do nothing if I gotta be the one tell you to spend. These fuck niggas telling for nothing, and I gotta be the one calling them friend. Drop top Rolls Royce, I don't know the kind, I don't know the name of it. Fuck this little bitch last night and this morning, but I don't know the name of it. She told that pussy she don't know nothing about him, and they fuck their fame up. We want the same mud, not the green, my nigga, the same mud.
Like he shooting schools up, yellow wide body, Hellcat look like a school bus. Dove up in that water, I ain't had no scuba. Glock on my lap, up and blow like a tuba. You just a hang bitch, I don't get two fucks. You just like to talk a lot, you ain't finna do nothing. They just like to pocket watch, so I got some zippers for 'em. I got P's and zippers for 'em.
Guys, मैं जा रहा हूँ. I'm tired now and I'll not do the part 2 of this stream. I'll just do some work off stream and then I don't know if I'm going to be able to stream